Okay, in this video, I would like to go over a couple of problems from section a.2 in our math analysis class. In particular, I'd like to go to review a couple of the problems dealing with radicals. All right, so here's the first one I want to review. It's question 83b, and there's the problem. And this is what I suggest. Break the 75 into 25 times 3. The x squared leave alone. The y to the negative 4, flip over the base, and write it as y squared times y squared. Okay, now we take the square root of that, and we look for pairs. And we can take the square root of 25 and get 5. We can take the square root of x squared and get x. We can cannot take the square root of 3, and well, anyways, not in a nice way, so we'll just leave the 3 there. We will take the square root of y squared and get a y, and then we can take the square root of the other y squared and get a second y, and get the final answer of 5x square root of 3 all over y squared. And when you take the square root of a variable that's squared, we do get absolute values to be technically correct, but it's something that I'll discuss in a different lesson. So for right now, let's leave the answer this way. Okay, so we're done with that. Okay, the next question I would like to go over is a cube root problem. Here we have the cube root of 16 over 27. What I want you to see is that the cube root applies to both the 16, the numerator, and the denominator. So we have the cube root of 16 and the cube root of 27. So I'm going to break down the 16 as 2 times 2 times 2 times 2. The 27, break it down as 3 times 3 times 3. Okay, now, in order to simplify this, I need to look for triplets. And here we have a triplet of 2's. And that's what you need for 1, 2 to come out. You need 3 of them, a triplet. And so to simplify that, we get 1, 2 comes out, but this last 2 stays outside, or stays inside. Now let's do the 3's. We need 3 3's for 1 3 to come out, and that's what we have, a triplet. And that is it. That's the answer. Okay, one more problem here that I'd like to go over, and that is 69b. A couple of things are going on here. The first thing is that I see is that we have a negative fraction as an exponent, and what I'm going to suggest is just flip the base around, and the base happens to be a fraction, so I'm going to flip that around and get the square root of 32 over 1. And that's how you make these negative exponents into positive exponents. Okay, now, it's a little bit strange to have a radical and also have a fraction as an exponent. Now, in class, we talked about that there's a relationship between radicals and fractional exponents. Oh, sorry, let me make this letter M. Okay, and the relationship is that you can rewrite this expression as a to the power m over n, where n is the root. And so what I'm going to, so let's come back to the problem here, and what I'm going to suggest is for you to rewrite that square root. Now, the square root, there's an imaginary 2 here, as 32 to the 1/2 power. And you still have the 2/5 on the outside. Okay, so the 32 to the 1/2 is exactly the same as the square root of 32. Exactly the same, based on this formula here. Okay, so now we have two fractions that we are going to multiply, and if we cross cancel, the 2's cancel out, and we simply have 32 to the 1/5 power, which is equivalent to the 5th root of 32, and that reduces to 2. Why? Because 2 times 2 times 2 times 2 times another 2 equals 32. So 2 is the answer I'm looking for. And that is it.